What do you want to know?
Can you go over like files, like mainly how to import them and the exceptions and stuff we use?
Yeah, we can do that. Okay, so okay, so let's create a new file here.
Are you recording this Zoom, by the way? Like, could you post it afterwards?
Yeah, I'm recording it. Yep, thought it was, but no, I am. I'm for sure doing that. Okay, so let's see what file I have out there that I can pop up, or we can just create a new one real quick. Let's do that. Okay, so the thing to remember about files, okay, and first off, every program should have comments that make sense with at least your name, what the program's doing, and we need def main in every single one of our programs. Okay, so no matter what, we're going to have that. It goes without saying. Okay. So when we're creating a file, variables we have normally point to an address in memory. When we're creating a file using the open command, it's going to give us, in essence, a memory address that the operating system has mapped a file to. Okay, so we're able to get to a file. Okay, so for example, let's do an out file. We're going to create a file. So out file, call it whatever you want. Any valid name is okay. But if out file, we're going to open up a file. Okay, I'm going to call this review.txt. Remember, Python can do text files or binary files, but we're only doing the text files in this class. They can also do sequential or direct access. We're only doing sequential access. Okay. The three modes we have read, which we're not doing in this case. We have write, which we can do. And we have append, A for append. Remember that write will wipe out an existing file. Append, if there's no file, it will create one. If there's already a file, it will add to it. Okay. So once I've done this, I out file, and again, I can call it whatever I want. Out file is an address where I can get to a file on my hard drive. Okay. So to create this file, I just have to write some stuff. So if I want to, I don't know, write some words. Okay, I could do, let's see, for C in range, I don't know, 5. So we do it 5 times. I'm gonna get some string. Okay, so let's do an s is equal to input, give me a word. Okay, and then I can do an out file.write. I can write that s, that string, plus a new line character. Okay, and then do an out file.close. Okay, so when I run this, assuming I've typed it all in correctly, got to give it a name, don't care. Okay, give me a word. So I can do hello, I can do monkey, I can do dog, I can do cat, I can do pineapple. Okay, that's it, we're done. Okay, and we can now check, we can look to see if this review.txt is out there. There it is, open up, and sure enough, it has the 5 things that we input with a new line character between them. Okay, so the next, are there questions on that, on creating a file? So if I want to add 5 more words, I just changed it to append. If I left it as write, it would just give me the 5 new words, but this is going to add to what I've got. Okay, so I'm going to run it again. I have to think of things. Do colors, do green, do blue, do yellow, do red, do black. Okay. So now when I look at the file, it should contain all that we had before, plus the new things. Okay. So that's what the write looks like. That's what the append looks like. Okay. Again, if I would have done the right again, it would have wiped out what was there. Okay. So now let's look at if we want to do something with the file to read it. So we have an in file. Okay. Again, it's file name, but that's what I like to call it. Okay. It's going to be an open. I'm going to open my review.txt again, but this time in read mode. Okay. So remember the easiest way when it works, just do a contents equal to infile.read and then an infile.close. Okay, and then I can print contents. That's going to just do the whole thing. It's going to print the whole file like that. Okay, which is not particularly useful. So what we do instead is the following. We'll do a loop here. So we'll start with a line outside of the loop equal infile.read line. So the read line is going to read that first line, including the new line character, into the variable line. Okay. It's going to keep doing that until it gets to the end. When it gets to the end, it's just going to return a blank string. So I can say while line is not equal to just two quotes right in a row. Okay. I can print line. And then I have to do a line again to get the next one. Okay. That should go through the file and print out every one. I need to close my file. If you don't close your file, it will still work, but I will take points off. Okay, so that's gone through and read those. Okay. Now, and what I should have done before, but didn't, every program that you do on the exam and all the homework should check for exceptions. Okay, so you have to think where could an exception be caused? Okay, anytime you have a file, there's an IO exception. The other exceptions we run into a lot, if there's a list, there could be an index error exception. If we're doing the int or the float functions, we can get a value error. If someone types in something just in general and it's not the right type, we can get a value error. So that's what we have to check for. In this case, all we have to worry about is the file. So even this one needs one. Okay, and I highlight all the text, hit tab. Again, my habit is to do the whole program, get it working, then add the exceptions. But you certainly could do something different. Okay. So I put the try across everything. I do an except, in this case, the IO error. Okay. I can either do something custom or I can just do as an ERR like that, and then just print that ERR. Okay. And that's all I have to do with this one. And you can see if this is working by making a typo in your file. And then if you run it, that should be what hits. And it does. Yep. No such file or directory. Okay. So that should fix that. Remember with the try excepts, you could also, if the program needs it, you can do an else, which happens if no exceptions occur, and a finally that happens whether they do or not. So those are two other clauses that you can have. Okay. The other thing about exceptions, you only need to put them in the main. So if there's an issue in a function, it will stop that function, go back to main so you can capture it there. In some of your homework problems, I'm seeing try catch blocks all over the place, and you probably don't need them all over the place. One big one works just fine, protects all your code. Okay. So Brady, questions about that? Is that what you were looking for?
Yeah, that's what I was looking for. So, and we can use try just in main, correct? Like you said, like it doesn't have to be in every function.
Nope, it should not be in every function.
Can you review like how to use different variables in different functions?
Okay, so functions are funny sometimes with variables. Okay, so here in main, we've got x equal to 12, let's say. Okay, I want to call another function def, my old friend double it, which takes a variable. Okay, and so if I then call it, if I then say print double it x, what that's really doing is it's setting, let's call this a different variable. Let's call that n. it's setting n in the function to 12, which is the value of x when x is passed in as a parameter, okay? So if I were to change this, say n is equal to n to double it times 2, and then return n, okay? In this case, I'm not going to get any side effects that the variable x and the variable n are separate, so it's not going to matter, okay? So I don't have to worry about that, okay? On any function we have, though, I do have to, this should just be automatically in your mind, I have to think of preconditions, okay? In this case, preconditions is that, let's say n is an integer, or a float, could be okay. Either of those, okay? And for post conditions, I'm not sure there is one. We're not assuming it's greater than 0, so we can't say that n is greater than n when it first came in or any of that stuff. So I'm just going to say none for that. But you need to say none. You need to be thinking about it even if it's not, okay? So to test these preconditions, I could do something like if not is instance in int, or not is instance in float. Then you want to return, say, negative 99 is my error. If not, you can calculate those, okay? So that should work as far as I know. Let me run this here and see if I've done something dumb. It doesn't like that. Why doesn't it like that? So it thinks that they're not. So let's just print this out. It's very interesting. I'm sure I've got the syntax of that not wrong. Instance in int. See what that is. That is true. Okay. So, oh, it's because of the or. So I'll have to think about this. This could get confusing. Let's just do it in 2. That's the cheap way out, but we can do it that way. So we can say if that return negative 99. You can just make the assumption. Let's just make it easy on ourselves. I didn't say what it had to be. Just say it has to be a float or an int. That should work. Yeah, that should work. Not sure what that was doing exactly. My if and ands and nots were getting confused. Now it's got some other problem. Oh, somehow in all that, I got rid of that. I don't need that print anymore. Okay, that correctly gives 24. Okay, but now if I would send along something else, 12.4, then it's going to return the negative 99. And the same way, and that wouldn't matter so much. What if I send a string? We really don't want it to do that. Okay, so that would also tell us that. I mean, we could also, and then, we could up here in our print deal with that if it's a negative 99 or whatever, but that's the basic ideas, okay? But the only problem we have is if we're sending something, because strings are immutable, ints are immutable, floats are immutable, but lists are not, okay? Lists are where things get funny. So if I were to send a list, x is equal to 1, 2, 3 for whatever reason, okay? And then down in here, I want to say that n is a list of ints, which could be an issue to think about here. So we can check for this to see if this is true, okay? And then let's say we want to do since I want to change, no, I'm just going to print them out. So I can say for some other variable z in n. Oh no, that they do want to create a new list. Okay, so in this case, I'm going to create a new list. Okay, so I'm going to say n2 is equal to an empty list. And as I go through, okay, for z in n, every time through, I'm going to set some variable num. No, I don't have to do that. I can just do an n2 dot append z times 2. I could type. Okay. So that's going to go through and create this n2 variable. Okay. And that should work okay. But if at the end I decide, well, no, it's not. Because if I say something up here, I'm trying to think of an example where there's trouble. If we send it, let's just, this is too convoluted. Let's make a simple example so we're clear. I have no idea what that's doing. There we go. We send an X, okay. And if I were to say in here, call it something else, doesn't matter. A, and then say that A sub 0 is equal to 200, okay. And let's call this and print X. Then you see that this line here, even though I'm changing A, because I'm sending X, I've sent a live copy of the memory address of X, and it made changes back in the main. Okay, that's kind of a convoluted example, but that's the issue. Okay, so the way to avoid that, so in this case, you would have a post condition that A is not changed. We'd have to do something like A2 is equal to A bracket colon bracket. That's the slice of the whole thing. And then you deal with A2. And this doesn't have the side effects. You've protected that. Okay, so if you run this, you're going to get the original 1, 2, 3. Hopefully that was made sense. That answer your question?
Yes.
Okay. So sending tuples, you don't have to worry about. Sending, but lists you have to worry about. Int strings you don't have to worry about. What else do
You
you want
said
to
we
know?
didn't have to worry about sending tuples.
There's no, you don't have to worry about side effects. They can't be changed.
Oh, okay.
I mean, you send them like anything else. If we just do this, now X is a tuple. Okay, then down here, this is going to give us an error. First of all, we can't do that. But that's going to give us an error. It's not going to let us make that change because it's a tuple. Okay. So we don't have to worry about it changing because you can't. It'll stop you from changing it. Okay. Same thing when you're sending a string. Strings are immutable. You don't have to worry about it changing. Okay, make sense? Other questions?
So when we have like a file with numbers, we'll need to write like a for loop first to put it all into a list before we can do anything, right?
Depends on what you're doing, but yeah, that's a good way to capture it. And remember that everything in a file is a string. So you have to, well, let's just do that. Okay, so let's say we've got a file. We've got whatever we've got. File, save as, num.txt. I want it to be, going to ask me oddly enough to use a txt. Yeah. Okay, so let's say we've got that file. Okay, so I want to read it. So I have my in file is equal to open. What I call it, num.txt. Open it for reading. Okay, so I'm going to have to go through this with a loop anyway. Okay, so I'm going to have my line is equal to, well, I can do a for with a file, but that doesn't give us a lot of things. So I'm just going to do it this way. So my line is equal to in file dot read line. Okay, it's going to give me my first line. I'm going to have my while line not equal to nothing. Okay, so line now equals that first number, the 23. Okay, but it's going to be a 23 and a new line character. So I can just go ahead and check that by printing line. Okay, at this point. And then of course I need my line is equal to in file dot read line. Okay, and then my in file dot close. Okay. Okay, and that's giving us the new line character between them, which we don't want. Okay, and we could try. I don't think it's going to allow us to convert without getting the new line, but let's try. It may. Okay, so I can do here. Let's say we want to turn it into a list of those numbers in my file. Okay, so again, this starts the reading of the file. I'm going to go through, instead of printing it, I'm going to say a.append line. I'm going to do it an int line. Okay, this may blow up. We'll see. No, it seemed to work. That's quite odd. It must know that that's Python trying to take care of you. Let's make sure that. Oh, I didn't do anything. I didn't print anything, so I don't know what I got. Let's see. But yeah, I was worried about that. But when I'm done here, then I could do print a. Try that. Yeah, that seems okay. Okay, and that's a common thing to have to do for sure. And of course, this would need 2 exceptions. No, this would need 3 exceptions. Okay, so this would need an IO exception because we're using a file. And again, in idle, at least, if you get the message name, the error name right, it turns purple, which is what you want. Since we're using the int function, we have a value error as a possibility. And finally, since we have a list, we have an index error as a possibility. Okay. Now remember, if you're going to write a number to a file, you have to use the str function to convert it to a string and then add the new line character to it through concatenation. Okay. To answer your question, that seemed like a long way around.
Yeah, it did.
Okay. Other questions? Okay, as far as general hints go, make sure you put in comments that are reasonable. It should have the name of the program and your name. You want to make sure you're capturing all exceptions. When in doubt, put an except in there, even if you don't need it. If you're not sure there could be a division by 0, it doesn't hurt anything to have it in there anyway. Okay, so be familiar with that. Again, the test is that there are 4 problems. I've got 3 of them I'm happy with. I wrote one test and I don't like one of the questions. I'm going to change it. But it's going to be on functions. You've got a main function in every program. So you're going to lose points if you don't put a main function in there. Okay, so you definitely need a main function. And functions in general, you have to worry about the preconditions and postconditions. Remember, sometimes we need an assert when it's possible. If there's something we can assert about the output of the function, we can put the assert in, and it can be caught with an assert error, okay, or maybe an assertion error, I forget which one. And then just be careful that the things you send in, if you're sending in 3 items to your function, then if you call it with just 2 or 4, it's going to give you an error. So you have to match those up. Okay. And remember, you can return more than one thing from a function. You can say like XY is equal to function name, whatever. And then as long as you return 2 values, comma delimited, that will come back into those 2 variables. Okay. So you can do multiple things that you return at once, which is kind of cool because you can't do that in some other languages. Okay. So that's really the main things about functions. Okay, just remember that remember the preconditions, postconditions. Remember to address those, because I'm not going to say that on the test, but it's important. No matter what.
Are you going to take points off if we only do one function?
If
Like
I do,
if we
what?
don't do multiple functions.
If I
will we
ask for
get points?
functions, yeah. If I specifically ask for functions, if I say create a function that does this and you don't create a function, you lose points.
Right. Okay.
Not all the points because you did the thing, but if I ask for a function, then you need to create a function. Okay. If I don't ask for a function, but you think it makes more sense, I'm probably not going to take points off unless I've seen some of the homework problems where people create like 1,000 functions for no reason. And you don't want to do that either. So it can get ridiculous. But in general, if in doubt, make it a function. As long as it works, I'm good with it. Okay. Remember, I haven't talked about it lately, but remember, if you need something that's accessible from all functions everywhere, you can declare it before your def main as a global constant. And sometimes that can be a good thing, can help out your code, but don't rely on that unless you need to. Okay. So that's the big issues out of chapter 5. Okay. Again, my general advice, don't print in a function unless all you do is print in a function. I think that should always hold true. So better to pass a value back to main, print from main. All of your try except blocks should all be out in main, because if there's an error in the function, it's going to kick it back to main where you can catch it there one time. This makes your code look a lot cleaner. Okay. The files in general, I think there's really not much to it. You can only read them, write them, and append them. That's the only thing there. Watch what I say on the program to make sure if you're writing, whether I want to write or an append. I'll say either you need to maintain the file or always create a new file, and that will give you the clue whether to make it a write or append if I ask that kind of a question. Okay. And then those all have the IO error exception you have to worry about. Not much else with that, except remember they're always strings, and the way we're organizing, there's always a new line character at the end. So numbers have to be converted to a string, add a new line before they're written. They have to be converted from a string back to a number when they come back out. And that requires a value error exception to be ready for it. Okay. I think that's about it there. There may be other things, but that's the general idea. As far as lists go, lists are really fundamental to everything we do in code. Understanding chapter 7 is important because if you understand lists, you should understand tuples, and really strings aren't much different either. So those functions make sense. I did look at the cheat sheet, which you're able to print out if you want, and I encourage it, bring it to the test. The cheat sheet has the string functions. It has the list functions. They're all there. So you don't have to memorize those. Just know where they are in the sheet, but it doesn't explain them. You have to know what they mean, but you don't have to memorize them. Okay. So remember, lists are immutable, and it means you can change the individual. Sorry, I get that wrong every time. Lists are mutable, which means they can be changed. Tuples are like lists, but they're immutable. They can't be changed. Okay. So all of the functions, all the slices, using the for loop to go through things, the not, in, and in, all that's exactly the same for lists and tuples. The only difference is the functions that change the internal structure of the tuple, like there's no assign for a tuple. So you can assign to a list, you can't assign to a tuple. You can't replace in a tuple, but everything else works. Okay. And then chapter 8, also remember, be ready for a 2-dimensional with the rows and columns. Remember you'll always do the for R in rows. You can use a global constant to give the capital rows for the dimension of how many rows you have, capital columns for that. So you can keep track of that. So for R and rows, for C and calls, you then go through and that's going to give you each item row by row. So yeah, you should be able to total up a matrix and all those things. Pretty straightforward. That should, I'm not going to give you something super complicated. Okay. And then strings, the weird thing about strings is that we typically just think of the way we've done in class. We're going to create a blank string, and then we're going to go through our existing string character by character, and then concatenate. Remember, we can't do an append doesn't work, but I can say S is equal to S plus something else, and it will create a new string where I can go through and do each one. Okay. So that's the general way you do it. You create an answer string that's empty. You go through the input string, you check it, and then either include it or change it or do whatever you want. Think of the one where we put the spaces in with the words, do all those things and write out the new string. And then at the end, you set the old string equal to the new string. Okay. That's a general way that those work. Strings are immutable, also can't be changed. So you can index a string. You can say S sub 3 to refer to the fourth character of the string. You can do a 4ch in S, and it's going to go through character by character. But you can't change. You can't say S sub 3 is equal to T. That would not work. Okay. But yeah, the data structures all kind of work very similar ways. You can do an in and not in with strings, so nothing really new there. Okay. Questions on any of that or on anything else? Remember, the split is important. I forgot about that. The split function of the string is super important, and it turns a string into a list based on some character that divides it up. Now you can always use the list function to, let me just share that, make sure we're clear on that one. Okay, so if I have a string, but I do need that rounded. So I've got my hello there as a string. Okay, if I create a list out of this using the list function, which I can do, the list takes, as it says here, anything iterable. Okay, so I can do that on S, and that's fine, but I get that. That may be not what you want. Okay, a better way in that case is probably to do S dot split. And by default, it's going to split it based on the space, which looks like that. Okay, which makes a lot of sense. So if you ever have something in your data like that, common and limited data, okay, if I say B is equal to S dot split on the comma, then that turns this into this. Okay, so that's super valuable to know that, right? What other questions do you have on that? And there's some string functions there too. Okay. So if no other questions, here's what I would do. So tomorrow it's going to be the review. I'm going to go through some of what I've just gone over today and open it up for more questions. Okay. So between now and then, I would look at homework problems that were assigned, homework problems that were not assigned, try to work those, make sure you understand. And I'll give you the warning I always give, but people don't pay attention. You know, people are. If you Google how to do something, it's likely to give you different ways that we haven't talked about yet, and it's likely to just confuse you. At this point in your programming career, you don't need to know 5 ways to do something. If you know one way, that'll keep your head clearer. So if you've got a question that something's not working, you don't understand it, don't Google it. Send me a message, send me a text. I will answer you, or I'll do a video on it. Okay. At this point, I don't want you to confuse yourself with code that we're not ready to see yet. Okay. I think it will be helpful or hurtful rather than helpful to do that. Okay. So I would do some more programs, make sure you have it down, make sure you can do those quickly. If you do them so much that they just become stupid simple, then you're ready for the exam. If you're not there, keep working on them until you're like, oh, I can't believe I've done this 1,000 times. I know how to do it. I know I'm ready for a test when I'm sick of it. If you're sick of the material, then you're ready. Okay. Any final questions? Okay. This video and the one from the middle set, I didn't do the first one, but the middle class video should be out there. They had a few questions. I'll post that as well. And those should be up on Moodle later today. Okay. See you guys tomorrow.
Everything just be posted like where the other videos are.
Yeah, they should be posted on week 10. Yep.